So in this video I am going to solve a problem for tank circuit. An inductive circuit of resonance 2 ohm and inductance 0.01 Henry is connected to a 250 volt 50 Hz supply. What capacitance must be connected in parallel with this inductive circuit to produce resonance? Find the total current from the supply and the current in each branch. Here RL circuit and capacitor circuit are connected in parallel. So one is a RL circuit, so this is RL circuit, and here this is a capacitor circuit. That two are connected in parallel, and that combination is connected to a voltage source 250 volts 50 Hz. And Is is the current coming from the source, and IRL is the current in the RL circuit, and IC is the current in the capacitor circuit. So we know resonance frequency for the tank circuit is Fr equal to 1 by 2 pi root 1 by LC minus R by L whole square Hertz. So by using that expression we can find the value of C, because F is given and L value is given, R value is given. So if you substitute that values and C is only unknown, so we can find C. What is the value of C? So C here is 722 microfarad. So at that value the circuit, this tank circuit is under resonance. So what capacitance must be connected in parallel with this inductive circuit to produce resonance? So this is the value of the capacitor, 722 microfarad. And next questions are current in each branch. So to find current in the RL circuit, so current in the RL circuit is V by R plus J XL is the expression to find IRL. So IRL is equals to Vs by R plus J XL. So 250 by 2 plus J. So XL is omega L. Omega is 2 pi F. So by using that expression we can find XL. So 0.0314. So converting this rectangular coordinates into polar coordinates, we get 2 at an angle of 0.9. So here if we solve this, we get IRL equal to 125 at an angle of minus 0.9 degrees. So again into the rectangular coordinates, 125 minus J 2 amperes. So similarly IC is equals to Vs by minus J XC. So which is equals to Vs is 250 volts, 250 at an angle of 0, and XC is 4.41. So if you convert this into the polar coordinates, 4.41 at an angle of minus 90 degrees, which is equals to 56.69 at an angle of 90 degrees. So IC is equals to 0 plus J 56.69 amperes. So this is the current in the capacitor. So we know now current in the RL circuit is 125 minus J 2 amperes, and current in the capacitor circuit is 0 plus J 56.69. So IRL plus IC is the supply current. So now total current from the supply, Is is equals to IRL plus IC. So adding that two currents IRL and IC, we get Is is equals to 125 plus J 54.69. So Is is equals to 136.44 at an angle of 23.63 degrees amperes. So that is the total supply current. So here we are asked to find what is the capacitor for the circuit to be resonance. So R value is given and inductor value is given, supply voltage is given at 50 Hz. What is the, so circuit is under resonance at 50 Hz, then what is the value of C for that? And the next questions are what are the currents IRL, branch currents IRL and IC, and after that what is the supply current.